Hi, welcome again. Let's look at how we can get the work done by the gas in an isothermal expansion. Before we can derive the work done by the gas in an isothermal expansion, we need to know that an isothermal expansion is a thermodynamic process. And this is a thermodynamic process which takes place at a constant temperature. So if that is the case, let's assume that the gas expands by a small amount, change in V. That is a change in volume, expands by a small amount, change in V, at a pressure. Let's not say constant pressure, at a pressure P. Suppose the gas expands or changes by a small amount, change in V at a constant what? Pressure. During an isothermal process, where this V, where the small amount change in V is got by, it is from V1 to V2. The volume changes from V1, the initial amount, to volume V2. So in this case, work done by the gas is got by saying change in W is force times the distance. I will have, okay, the work done in this case, I will not use force, but we know that work done is P, since we are talking of pressure, is pressure times change in volume. So this can be written as dW equal to P dV in this case. So to get the total work done by the gas during an isothermal expansion, so we shall say total work done. For us to get the total work done, we apply the integral on both sides. And then this side, we shall have the limits being from V1 to V what? To V2. So I'll have integral of dW equal to integral from V1 to V2. But this we shall have P dV. Okay? That's what we shall have. So in this case, this implies that this integral sign and the differential sign will go. So I'll have the total work done will be integral from V1 to V2 P dV. But of course, this P we can come for an ideal gas. Okay, we are dealing with an ideal gas. PV equal to N RT. This is the equation of state, or the equation of an ideal gas. So we shall have that. In this case, P becomes, because I am differentiating with respect to V, so I have to bring in the aspect of V from this equation. So I'll have that N RT out of V is P. So I substitute for P back here. So therefore, I will have that work done will be equal to integral from V1 to V2, and I'll have this P is N RT out of V dV. So you realize that N RT become constants, and we can factorize them out. And for that case, therefore, I will have that the work done will be equal to integral from V1 to V2. I'll have N RT. Let me first recopy it here, dV. So this implies that work done is N RT integral from V1 to V2, 1 out of V dV. So in integration, when I integrate the reciprocal of V, I will get a ln of V. So therefore, I will have work done is equal to nRT, and then I will have this one becomes ln V, and we are moving from V1 to V2. So I am going to replace my limits starting from the upper limit, and then I replace the lower limit and subtracting them. So the total work done is nRT. Then I'll have this is going to be ln of V2 minus a ln of V1. So that is what we have. But then this is just a natural logarithm. So from the laws of logarithm, so if I have a ln of v2 minus a ln of v1, it is the same as having as a ln, one ln, then I have v2 minus v1. So therefore, I'll have that the work done is equal to n RT. Then I will have a ln of this one becomes v2 out of v1. This gives us the work done by an expanding gas during an isothermal process. And this is for n moles of the gas. Now, for 1 mole of the gas, that means n equal to 1. So meaning work done becomes RT ln of V2 out of V1. Now, this equation talks a lot in itself. If V2 is greater than V1, then it means the work done is going to be positive. You can try to get a ln of a bigger value divided by a smaller value. You're going to get a positive answer. So meaning our work done is going to be positive if V2 is greater than V1. So that means the work is being done by the gas itself. In this case, the work is being done by the gas. Maybe expansion. So it means when V2 is greater than V1, it is an expansion happening. So the work is being done by the gas. And if it happens that our V2 is less than V1, then the work done that we are going to get will be negative. So that means a compression is happening, and so the work is being done against the gas itself, or work is done on the gas. So there is an external agent that is doing work on the gas or against the gas. So this V2 out of V1 tells us a lot. But again, for an isothermal process, we have to know that a gas that is undergoing an isothermal process obeys Boyle's law. We are actually, maybe we shall talk about that again. But a gas that is undergoing an isothermal process, expansion or a compression, it obeys Boyle's law. So it follows from Boyle's law. From Boyle's law that PV is equal to a constant. And if that is the case, if PB is a constant, what does it mean? What does that mean? If PV is a constant, then it means that P1 V1 will be equal to P2 V2 is equal to P2 P3 and all that. Okay? Maybe equal to P3 V3. It depends on how many processes you will undergo. All of them are the same. So that means when I come there, it means work done can be written as P1 V1, okay, because we know that this is equal to N R T, okay, and for 1 mole is equal to RT then. But then if that's the case, we are going to replace. So that means this is what we are calling, it's a constant. Because his temperature also, N is the number of moles, that doesn't change. R is the molar gas constant, and T is the temperature. Because we are dealing with an isothermal process, so this temperature is going to be constant. So in that case, so if that's the case, therefore work done is going to be, instead of RT, I'll have P1, V1, a ln of now V2 out of V1. Or we can even have it as work done. The same work done can also be P2, V2, ln of V2 over V1 in that case. So ideally, it means this can give us the work done. This can also give us work done, since this and this are the same. So we can have that P1, V1, ln of V2 out of V1 is equal to P2 V2 ln of V2 over V1. We can as well have it this way. So either use this, you can still get the work done, and also this way you can still get the work. I can put work done here, no problem. So that is the expression of work done by an expanding gas or a compressed gas. You can see at the end of it all, when you calculate that work done, you actually know whether the gas underwent expansion or it was compressed. Thank you very much. Thanks for following. Subscribe to get more updates. Thanks for following me.